So this is our fundamentals track. Hi, panel. Thank you for being here. Appreciate you. I, as an engineer and a creative, and not a physicist, would love to have a conversation with the fundamentals panelists about how alternatives at the fundamental level will affect personal AI user experience, and just from a consumer level, how is what you're doing very low end going to affect the people using the technology? So, Reza, I'd like to start with you and start with your work on fluid networks, fluid network models. And how can fluid networks help personal AI specifically? Will they will we benefit from a UX perspective, or is it more performance based?
I think it's more performance. I think what my motivation was twofold. One was an efficiency. Is there a more compute efficient way of running neural networks based on the laws of physics? And ultimately, I think there is a part, that thing I disparaged and said is intellectual laziness. It kind of is. But there are parts of problems where we really don't have the mathematical formula behind it, and there's no rules and procedure, no sort of formal stepwise method of solving a problem, but we've got lots of data. So I think it ends up being a mix of the two. I'd love to create a tool that'll take a deep neural network and break it down into a causal network and a probable network. So it's a causal network, which would be based on laws of physics or some other set of defined laws, and a probable network, which will be basically a smaller version of the initial model. For instance, a large language model. Well, so what are the rules? What is the physics inside language? Well, there's grammar, there's syntax, there's an established dictionary, a vocabulary. Those are formal. Those are formal and algorithmic. It's not based just purely on correlation. So you could actually take an existing large language model, decompose it into something that's a causal network and one that's a probable network. And that's, I think, what can happen. The ultimate result is it'll take up less computation and could possibly run on a mobile device, on a wearable, or something like that. John.
Okay.
So I'm going to start with, in the early days of cloud, they put me on a panel, and I didn't know the guy next to me had did the sequencing of the DNA. So I argued with him. And then I got off the panel, and they told me, did you know who that guy did? This time I actually know I've got 2 brilliant guys besides me, so I feel like an imposter right now. No, I think that my point is, I'm not a data scientist. I didn't get a degree in AI. I've been sort of crawling my way out of this sort of what this thing is. But for those of you who saw my presentation, I'm looking at the practical implementations of how this stuff, it looks like I missed your amazing presentation, but I'm a big fan of Daniel Kahneman, thinking fast and slow, the neuro symbolic, the structure which seems like it's built on that. I think a lot of the things that we think about, is like, how do we turn data into sort of information, which turns into knowledge, which turns into understanding, which may be wisdom, I don't know. But the point being, there's so much data in an enterprise. The IDC did a report last year, an analysis that said 90% of the data in an enterprise, an organization, is unstructured data. And so we spend 90% of our time trying to wrangle the 10%. The real advance here, the things that I see that these LLMs or these neural networks, or the way that we can sort of compose this data into something up the chain, is that's the voice of the organization. The way an organization, like, if a certain organization is really good at channel partners, if another organization is great at supply chain, that's all that 90%. That's a tacit knowledge. It's the knowledge that Sue has in a spreadsheet, Bill has in an email. It's communication vehicles. So if we can tap into that in a way that allows us to sort of to understand our organization and our strengths and our weaknesses. I think, and I think just catching your presentation, I think there's a tremendous opportunity. Because one of the things we do in DevOps is we try to, not through sort of science, but try to figure out what these pockets of ignorance. What's his face? Paul O'Neill called them pockets of ignorance in an organization, right? If we could use some type of network like that, or the neural symbolic networks, to help us find out where our sort of strengths are and our pockets of ignorance, I'm all in.
So Khai, I actually want to change up the question for you actually a little bit. Sorry. I'm curious, like, based on what Reza said about fluid networks and what John just said about LLMs and how they can sort of probably be broken down to do both things. I want to ask, do you think reasoning models will replace LLMs, or will they coexist? Or is there, what do you foresee it in that light?
The end game is to have reasoning. The end game is to have knowledge. The end game is to have causation. Science is causation. So if today we have a perfect reasoning network on medicine or whatever on text, LLM is completely useless, because reasoning is logical, rational, not biased, and it's built on top of the data. So yeah, there are a lot of data, but geez, why don't we process knowledge? How many of us have, in our domain, we know only a very small piece of it. So if we just connect the whole dot, we will jump in terms of progress so much faster. I'm not saying we should not process data, but it's mining. It's like rock, and we have gold, and we don't use it.
That's great. I love that.
That's where I get myself in trouble. I mean, isn't bias part of the reasoning? So you said not to have bias, right? But bias is not necessarily a bad thing, right? I mean, the symbolic nature. Okay, anyway, yeah.
I didn't mention bias. I was saying exact. We cannot get rid of bias. Quantum mechanics told us that, right? As soon as you observe something, you already bias it. And interpretation is bias, because it's how we interpret it. So when people are chasing to have zero bias, it's nonsense.
All right. Okay. I had this question for Roman, but John, I think you might be able to have some insight on this. Do you foresee challenges in as engineers adopting different fundamental models in open source today? Like, is it easy to do, or?
Yeah, I mean, what I worry about more is sort of from the sort of, my whole career has been infrastructure and operations. I grew up, I started my career running large mainframes, then distributed computing. And what I see, so there's a little diversion of the answer, because I think these two guys are way more qualified to answer the network, the AI answers, is what I call the technical debt tsunami that is coming down the pike, that the CIO has no clue is going to happen. And so part of my workshop this morning, part of that short presentation, is to make aware the people that manage infrastructure and operations, if we call it DevOps, we call it DevSecOps, doesn't matter. We got to educate them really quickly. They have to understand what the terminology is. Because right now, groups like HR groups are coming in and dropping in these models and all these different ways of doing things that changes every 15 minutes. And we, the collective we, if you're going to DevOps days tomorrow, we don't even know what questions to ask. When our CIO is asking us, what do you think about this solution? When cloud came around, it was a little bit of a bump, but we knew network, storage, and compute. Okay, I get it now. Cloud is just network, storage, and compute. I'm on board now, CIO. I have a feeling right now, and I'm racing to catch up, that we don't really know what the components are here. And if we blink, and hey, dear CIO, we're writing a paper now called Dear CIO, which is going to be a plea to them to say, you have to educate, you have to get involved, and you need to start asking questions, because if you don't, you'll have 30 different variants of models that people use. You'll have 30 different variants of orchestration engines. You'll have 50 different vector databases. And they'll all be a tremendous amount of and I'll shut up here in a second, but I thought Ruby Gems was a disaster. The dependency map on Python libraries in this generative AI. I'll have something that worked for 2 months. It'll break on a Monday, and I'll get 6 pages of a stack trace of some library that's written by some PhD student that, and this is the world we live in. It is brittle, and we're going to have to manage this stuff because there's no stopping it. It's coming down, it's happening. And so I think our job is to get as educated, learn as much as we can from people like these, and really get educated and try to figure out what we can bottleneck and what we can't.
All right, thank you. And I'm curious, since Reza and Khai are actively in the community, I'm curious what your outlook is for adopting these fundamental models, or just sort of using them in the Kwaai community. How far is that outlook? Can we do it now? What can we play with?
Well, I think it's much needed research. I think we're showing that research is possible in this area, and it's needed. Look, part of the nightmares, the thing that haunted my dreams recently was the vision of a big landfill, a $7 trillion landfill. Okay, so you know what I mean. The $7 trillion landfill, based on this addiction on GPUs, that it's the height of intellectual laziness to say we don't know how to solve these problems. If a fraction of that was spent on working on causal neural networks or reasoning AI or smarter ways of doing things. John, you mentioned something, and it probably went over. You mentioned it really quickly. The cosine similarity. Okay, so what happens in neural networks is this matrix math. The dot, and a mathematician would recognize it as the dot product between two vectors. And what Geoffrey Hinton said, no, you just have to look at the similarity and just move forward. Don't worry about the difference. So the cosine between two vectors is measuring how these two vectors are aligned. And then we just go forward. And we go all the way through to the end of the network and realize, oh crap, there's a big difference. Now we have to go all the way backwards through backpropagation. There's better math. Use better math at each node. So geometric algebra computes both the alignment and the misalignment. Hey, if you were to do that, maybe you can get a network that learns as it thinks. So that's another area of investigation, using geometric algebra as the fundamental math in the perceptron, rather than just this lame dot product. Why do we do that? Because it's easy to compute on a GPU. And it's a self-fulfilling prophecy that GPUs, which were designed for video games, for shaders and rendering graphics, okay, it got other uses. People figured out how to mine Bitcoin on it. And now they've figured out how to run deep neural networks on it. And yeah, one company's getting super fabulously rich on it, but it's just fundamental intellectual laziness, not thinking of other ways of coming up with AI, implementing AI. Get off my soapbox.
And
So,
I want to hear from
yeah.
Khai, sorry, but do you have a question? Are you all right? We're going to hear from Khai, and then we're going to move to you. And anyone else who wants to ask a question or make a statement can go up to the microphone. All right.
Yeah, so the macro connectionism that I was talking about, as I mentioned, I work on that for 30 years. And the reason why, so I started to publish, but I realized that in the academic world, if you are not in the right trend, people don't listen to you. You have to mention papers that you are fundamentally not agree, because if you don't mention them, your paper is not accepted. I thought that the academic world was very open-minded, and I know it's video, but I will not return to academic world anyway. I wish the academic world really is open-minded place. So from there, I decided to build companies to prove that it works. So my first AI company was very successful. And this one, we started to have a very interesting traction. So the technology is no more like we don't know what it does. It's already have result. And I'm interested here to, it cannot be open source because there's a company behind, but I really want to find a way to open it. So I'm here to open to discussion, people who would be interested to work on unified AI, having the machine learning and the reasoning based on macro connectionism. Please come to me and we can talk, because I think this can help other domain than the one I am, which is life science today.
All right, great. Can we have your question?
Yes. Hi, I'm Adrian, the middle child, and I came all the way from San Diego to ask Dr. Pham this question. So, yeah.
There are Zoom.
So it's about explainable AI and if it should be a litmus test. My example is a documentary on the Challenger flight. And in the story, they explain that the program manager in Washington demanded that they launch because they'd become late and behind schedule. But that was at least someone being accountable and explaining it. So should explainability be a litmus test for AI?
So this is another misunderstanding topic. What I mean by that is you need to explain something is because these things is not clear. What I mean by that is you need explainable AI because it's a black box. But if your AI is already explicit as a human, right? If you tell me something, my first reaction to you, if I don't understand, I'm going to ask you why, and your answer is because, because. And then you're going to explain me what's going on right away based on how you do your reasoning. So explainable AI is needed when you have a black box system, which means mainly machine learning. The reasoning, a lot of time people say to me, okay, but what is the mathematics? What is the algorithm? No, with reasoning, you have an intermediate level, which is the knowledge level, the conceptual level. You don't need to go underneath to understand what's going on. If the knowledge level, the conceptual level is logic and rational. And this is how human we function. So explainable AI is super important, but not maybe the way that people think is to solve a problem because the system is a black box to start with.
One thing in that example, you know, I've studied the Columbia, and not from an AI perspective, but the Columbia and the Challenger postmortems, and I've done a lot of work on, you know, safety and resilience culture. There's been probably 15 books trying to explain what happened with Columbia. Diane Vaughan wrote a book, Normalization of Deviance. So whether it's AI or it's humans, explainable is a bias, right? So like, and you know, like I've been running a lot of sort of observability tools, like evaluation tools, and I've noticed there's a sort of phenomenon that I'm calling hallucinations of hallucinations, right? Which basically, and it sounds funny, but it's like I'll see something where it tells me it's a hallucination and it's the wrong answer, but actually for the corpus of data I'm using, it's the right answer. I found other scenarios where these hallucinations are telling me I didn't give as good of an answer. So again, that's just another form of what it's not, these are not AI terms for a non-AI guy, but they're biases. And so I think to sort of equivalate the notion of like humans give great answers when we have tragedies or wrong scenarios, and AI is going to have to do the same thing. That's incorrect. Humans do a terrible job of explaining disasters, and you know, and think about all the sort of mental models that go into how you sort of decouple something that happened, like the Challenger, Night Capital, you know, all these disasters.
Just one quick things here. When you talk about explanation, the next concept is understanding, right? You accept an explanation only when you say, okay, I understand it. Now, what does it mean, understand? Have you think about why suddenly you say, I understand, but what does that mean? It means that you were able to connect some of the new concept to the concept that you have. And you cannot do that with just notes that have no meanings.
Thank you. And we have time for one more quick question, and then we're going to move on to member voices. So everyone will have another chance to speak in a few minutes.
All right, I have just two comments, and I want to get the panel's view on what I'm going to talk about. The first thing is on correlation, and causation. I appreciate that there was some talk about the difference, because there's major confusion, even in higher circles that I see. First of all, some people think that if there is no correlation, then means no causation. That's totally false, as it was pointed out. Others think that correlation is necessary but not sufficient condition for causation. That's a little bit better, but even that is false, because correlation indicates only a linear relationship. So even if it's not correlated, the relationship could be more complex, like curve or space or other things. So those is one more reason to go for intelligent reasoning. But at the same time, I want to point out that I'm so impressed with the work that both Reza and Khai have done, and I hope that it's going to advance more. But I think even if we get more, that doesn't mean that there is no value for machine learning, neural networks, and all that, because there's some things that are happening, some phenomenon that we have no idea what are the factors that are causing it. So machine learning and artificial intelligence could point out that there is some relationship, so that it will direct the more advanced science-based people to go after and find out the causation. So there is still room for both. That's my point of view. And I don't know if the panel agrees or not.
I just want to rebound on your comment and what Reza was talking about, the $7 trillion things, right? Yeah, machine learning is great. It does amazing things. But you can put this money into some much more efficient and smart way to do it. This is the thing. So the voice I try to say here, hey, people are looking here, but geez, there is something here that is easier, fast. Oh, it can be complex to do it, but as a result, it's way more efficient.
So you all know the $7 trillion reference. That's Sam Altman's ask for, I need $7 trillion in order to build the data centers for my AI ambitions, or build new silicon to compute it. But I'm not sure that a fraction of that spent on something else. What don't you? There's another question, right? Okay.
That's very kind of you. Yeah, just one question, and actually just want to resonate with the group. You guys have heard of Eleuther AI, that they've offered a lot of data sets and things of that nature. So Eleuther AI did a study on actually what corpuses of data are actually utilized in neural networks, and they said that 92% of the data is not used 99% of the time. So I think that resonates with exactly what the gentlemen are talking about, that there's a signal versus noise. Now, the structure of the neural networks and how they're used, that's something for the the theorists to do, but I just wanted to resonate with the group and maybe get some feedback on that. And if you guys haven't seen the study, take a look at it. But yeah, right now they're using brute force, to your point, with the $7 trillion worth of GPUs, because we don't know where the signal is at, right? And so we're compensating that with brute force. And that was very kind of John Willis, but he's been I've been a big fan of his for well over a decade, but he's an amazing guy.
When you say we don't know, so we do brute force, yeah, and we'll continue to do not know by using the wrong tool. The other thing is the $7 trillion, even the thing itself is just crazy. Imagine how much today Microsoft saw 30% increase of their electricity consumption because of AI. Imagine $7 trillion in addition to that. Are you sure that our planet is going to handle that? Okay, so there are so many elements. So for me, it's more like an ego trip rather than a real market. Because maybe you can start with 1 trillion.
Actually, on that note, we're looking for contributions of equipment. So I don't know if Michael Larson's in the audience. Michael loaned us the Beast. So for quite a while, we've been running on his machine located somewhere in San Bernardino. Yeah, it's expensive to run these GPUs in the cloud. And so you're not going to get a movement to get you off the cloud. And that's not going to come from the hyperscalers themselves. They would love you to continue doing your computation in their cloud, and you pay the toll. Oh yeah, just upload all your data here, yeah, and we'll pay you a toll to go and visit it as well. So it's urgent. It's vitally important. It's a clear and present danger. The carbon footprint of today's AI is just disastrous. And so this is one of the areas we could have just purely focused on policy or purely focused on personal AI. The fact that we kicked off a research group to find better ways of doing neural networks, better ways of implementing AI, I think is answering a clear and present danger that AI represents today. How are we doing for time?
We have to wrap up.
Okay.
That was a wonderful conversation. I do want to. We're doing member voices next, so you will have a platform to talk.
Quick question for the panelists? Or just
I just wanted to share something with
all right, then this is a
everyone.
great segue. So, thank you, panelists. Really appreciate that. Very, very, very well done. This last part is my favorite part of every one of our Friday meetings, which is our member voices. And you don't have to be a member, although please go sign up on Kwaai.ai. We'd love for you to become one. We'd just love to hear from you, your thoughts, your opinions, feedback, questions, concerns. This is more of an informal session, kind of you to the group. Please, feel free to introduce yourself. I'd also just like to make a quick additional announcement again, and then I'll plug this in and see the thing. Come over for our mixer. We've got some fun little wristbands for you to visit the mixer. You'll hand those out to people. Thank you, Jordan. Appreciate that. He walked up, so I'm trying to delegate here. So yeah, please head over to the Hotel Dina afterwards, 5 o'clock till about 7-ish. We're not feeding you dinner, sorry, but come and hang out with this great group. So yes, would love for you to kick us off with member voices, please.
This is after a long time away from scale because of COVID. This is my first time back after COVID, but I just wanted to let everyone know that on April 10 of 2021, God showed me how to make an AGI machine on a single high-end desktop without using any large language model or anything like that. And when God showed me that, I was afraid to do anything with it for quite a while, but I've now decided to pursue it. And I have a website, jcartes.org, and I've written some basic ideas in an article there, and I'm planning to further develop this machine. And I'm using PostgreSQL as the starting point for writing the code. But I believe that it's possible to use a single high-end desktop without using any cloud storage whatsoever, and to produce an actual AGI machine that's local on a single PC.
That is fascinating, and you'd clearly be a good addition to our fundamentals work group at Kwaai. We'd love for you to sign up. We have a Slack work group. This is how we keep things up asynchronously. Lots of Slack channels going on. That fundamentals work group meets once a week as well to discuss these issues, and really focused on exactly that. How do we make these smarter, greener, and more efficient? Because if we can shrink them down to the size of a high-performance computer, if we can shrink it down to a device, then we can expand access. And so if everybody's got AGI in their desktop, not just a little agent, that is conducive to the democratization that we're trying to do here.
And the other thing is, when you talk about AGI, you have to realize that it cannot be controlled. There are two laws of intelligence.
We've got some folks behind you, so we can move on, and that's great mixer conversation as well. Let's get into that at the mixer.
All right.
Hey, Karsten, you've got.
Yep, just a quick one. Sure. Hi, my name's Karsten Wade, and I'm a person who digs in a lot about open source practices, best practices, and how not just how and what to do, but the why of we do things. And one of the things that's been really concerning me, not just with Kwaai, but all over, is the loose usage of the word open, and whether we talk about open source AI, whether it really is open source or not, and whether that matters. There's one viewpoint is, well, all of these licenses under Llama, for example, are really only going to block big companies, and it doesn't matter. It's not going to ever affect a small person like me. Well, maybe not. But one of the reasons why, et cetera, et cetera. So I have lots of things I thought about this. I'm curious if anybody else wants to talk about these topics. I just wanted to flag up and say I'm interested in it, and I'll be around at the mixer later. Thanks.
Yeah, absolutely. And Karsten's been a great member and community organizer. He also was the principal community architect for Red Hat for some time. So great person to know and understand how culture and technology fits together.
And he's speaking on Saturday.
Yeah, plug your talk.
Yeah, plug the gig.
Scale talk.
5 o'clock tomorrow.
Oh, he's doing a panel at 5 o'clock
Panel
tomorrow.
5 o'clock tomorrow. Karsten Wade. Jordan.
Yeah, hi, my name's Jordan. I saw Reza's Kwaai talk at DataCon in August and was blown away. Made a few introductions, and here we are. Thank you, everybody, for coming out to the Kwaai Summit, and thanks for all the Kwaai folks for making this thing happen. Yay. And as far as plugs are concerned, I host another co-located event called DevOps Day. It's tomorrow, Ballroom D. See you there. And if anybody needs a drink up ribbon, I got you. But thanks.
Thank you, Jordan.
Hi, my name is Sean. I'm a big fan of Kwaai, and thank you, Reza, for making all of this happen originally. And so I just wanted to plug a talk that I'm giving tomorrow morning at 10 a.m., which is entitled AI Recipes as Public Infrastructure. And so basically, it's a lot around how do we abstract the programming models such that many organizations can partake of these things. And so we'll talk about, in particular, how this is playing out with a bunch of low resource languages and some work that we've been doing that was demoed at the UN in April around farmers and how they're basically using RAG bots in many different languages, and then really allowing those things to be recycled and reused for many other organizations too. And so I feel like the merger of some of the concepts of these very high-level abstractions and all the great low-level work that you guys are doing in Kwaai is a place I would love to discuss and hopefully have that happen.
Yeah, thank you,
So
Sean.
10 o'clock tomorrow morning.
I see some familiar faces I usually only see on a Google Meet. I'd love for a few of you to come up to the microphone, introduce yourself. Some of the Kwaai members.
I can bring the microphone over to you if.
Yeah, or we can bring it to you. Well, one of the traditions is if you don't volunteer, we start asking.
Yeah.
We start calling on people.
Actually, I can think of one. Nathan, why don't you introduce yourself?
Sure. So
Excellent.
I'm Nathan. I've been playing around a lot with LLMs since they first came out, and I'm definitely excited to hear about Kwaai. Let's see, since I have the microphone, something I think is particularly interesting. I really enjoyed Bruce Schneier's talk on privacy and trust. My background's in AppSec, so I always find it really fascinating to find that intersection. I think in general, there's a lot of very difficult corporate incentives that really aren't aligned with a lot of incentives for how AI could work well for society. One thing I think is very interesting to think about is the potential of actual agency and sentience. The general consensus is not really a thing right now, but there was a really fascinating talk by David Chalmers at a Philosophy of Mind conference. And I think in general, there can be a lot of things that corporations won't really want to look into because it's very misaligned economically. And the open source community, I think, has more of an obligation to actually do that more in-depth research and answer some of these hard questions.
Hey, and plug your day job website. It's pretty cool.
Sure, yeah. I'm the CTO of a small healthcare, mental health art gallery called the Giving Gallery. So it's kind of like Etsy, multi-vendor marketplace. We sell artwork and a percentage of the proceeds go to mental health charities we're partnered with. We just partnered with Children's Hospital of LA last week, so it's pretty exciting.
What was that called again?
It's called the Giving Gallery.
Very good.
The Givers.
Okay, Matt, you want to...
Michael, would you say hello?
Raise your hand.
Oh, sorry. Oh, Eunice. Yeah, you, but Eunice.
Where? Right. Oh. Hey.
All right. Okay.
Nice to meet you.
Thanks for raising your hand, Eunice.
You'll pay for this, man. Well, my only job is to make sure that Kwaai has enough resources to produce the open source software. Actually, the people doing the work is the people of Arcus, Anna, Roman, and Sai, and a few other people. But I'm a big fan of the concept, big fan of the movement based on ethics and serving the community, so we don't make the same mistakes that we have made with the mobile phone, with the internet in general. So I appreciate the opportunity and looking forward to meeting all of you. Thank you.
Thank you so much, Eunice, and thank you so much to Arcus Nexus. Eunice is the CEO of Arcus Nexus, Kwaai's development partner. They've donated these amazing AI engineers for us. The quid pro quo is that these amazing folks are also getting some great training from some other amazing folks. So if you're working with a services organization and you want to join the party here, we'd love to have you in that way as well. We're about 3 minutes to the 5 o'clock. We could take maybe one, possibly two more hellos, and then I'm going to switch it over to Reza to send us out. Well, send us over to the Hotel Dina. Oh, yeah, here we go.
Oh, sorry. Thank you. My name is Khai. Reza, excellent presentation. You talked about causation and not correlation, and then you also mentioned a causal neural network. That whole concept of causation, particularly around business, the whole MMM, the marketing mix modeling, which every Fortune 500 company uses for MMM. An MMM is simply a statistical analysis as a multivariate regression on sales and marketing, and multiply times a series of data to estimate the impact of various marketing tactics on sales, and then they forecast them over the period of time. Every company does this. They're all wrong. They're all using correlation. I look forward to figuring out a method of having a causation or a neural network to actually put that into action that several companies can actually predict sales as opposed to just simply lazy.
Good question. So Ty, I'm going to take that one, and thanks so much for coming to the conference. I'm going to take that one and then take us into a wrap up. Okay, so yeah, my talk was about going back to physics to solve some very fundamental problems. Of course, if a tiger is running towards you, you don't have the time to think about Newton's equations of motion, what speed it's coming at you, and the aerodynamics of the hair going through that. No, you've got to think quickly, and that's the slow thinking and the fast thinking. So we've got one part of our brain that's fight or flight. It's a trigger reaction. Is that person a friend or foe? And then we've got a higher level of our brain, which is a bit more socialized. It's a bit more cerebral. And well, we need both those forms of thinking in our artificial intelligence. This is real intelligence, artificial intelligence. So when we're creating it, we also have to make those snap, blink decisions on certain things. And sometimes let's be in control of those blink decisions rather than leaving it hidden inside training data and so on. So it's the thing we call bias. It's a deviation from the answer, the question. In fintech, which is the area you asked the question, there's also a similar equation. Is it called the Black-Scholes equation, which looks like the Navier-Stokes equations? And there's a lot of money poured into solving that. There's data centers used to figure out, how the market's going to move. Look, yeah, if you follow the money, then a lot of AI is simply following the money. We don't individually represent that money, but as a collective force, consumers, individuals, users, we do wield a lot of power. And when that power is unified, we can make changes. We can make changes that are culturally significant. That is what the Kwaai movement is all about. It's about turning the tide, the monopolistic tide, the oligopoly that's controlling the industry at the moment is just unhealthy. It's actually unhealthy for the industry. It stifles small to medium businesses from participating. It's a winner-takes-all mentality. As I said before, in the board game Monopoly, when one person owns all the wealth, it's game over. And we don't want that, do we? In fact, if you played the game Monopoly and it gets to that game over stage, you find individuals saying, oh, well, why don't you take these properties over here and manage them for me? Why don't I give you some money? Oh, that's outside the rules. That's outside the rules of capitalism. It's humans being altruistic. Kwaai is an altruistic intervention to right the ship. So, call to action, join Kwaai if you haven't joined already. Tell your friends to join Kwaai. Figure out how you can participate in this movement. It's vitally important. And if you don't, ask yourself, why am I not doing this? But anyway, we're going to have a chance to meet the speakers and mingle over some entertainment and drinks and nibbles at the Hotel Dana. There you go. Look forward to carrying on the conversation. Thanks, everybody.